Okay, welcome to section 4 of the course, where we're going to talk about database services, relational, key value, and integrated query services. So our first video in this section will be about working with relational databases, specifically RDS and Aurora. We're going to go over how to add highly available, resilient database services to your well-architected cloud-native solutions. So, let's start out with the basics. What are the AWS Database Services? The RDS services are fully managed database services. And AWS has 15 purpose-built database engines in all categories, including relational, key value, document, in-memory, graph, time series, and ledger. And I have a diagram here showing the various types of purpose-built databases that AWS currently offers. And you can see relational has its typical capabilities of its ACID. It's got its relational integrity. You use it for transactions and schema on write. And typical use cases are CRM or finance. Relational is the database type that we've known forever. And it has always been thought of as the one-size-fits-all up until recently. And recently, AWS and others have introduced key value type databases, which have the characteristics of high throughput and low latency, and unlimited scale with DynamoDB. Typical use cases for these types of databases are e-commerce, social media, and customer preferences. Then we have our document database type, and AWS's offering here is DocumentDB, typically used to store JSON documents and to offer a query on any attribute. Typical use cases for these types of databases are content and personalization. AWS also offers in-memory databases, such as Redis and Memcached. And these are query by key and offer microsecond latency because they are in memory. Typically used for real-time analytics and cache. Then there are graph databases, and these are characterized by fast creation and navigation of relationships between data. Different type of structure of the database. And these are used for recommendation engines and networking applications. Then we have time series databases recently announced by AWS. These are data sequenced by time and typically used for IoT and event tracking types of applications. And then finally, the latest addition, the ledger database that AWS has. This database is immutable, so once a data element is written to this database, it can never change. So it has a verifiable history. And this is used primarily for finance, healthcare, and any system of record that needs an immutable database. So what you can do now with AWS's purpose-built databases is build your database solution using the appropriate type of database engine versus resorting to the one-size-fits-all approach. And then finally, these database types are protected with multi-factor authentication and monitored with auditing tools. So Amazon RDS, let's talk about RDS, the Relational Database Service. So you can quickly set up and scale relational databases in the cloud using RDS, and it's cost-efficient, resizable capacity. And there are 6 types: PostgreSQL, MySQL, MariaDB, Oracle, SQL Server, and finally Aurora, Amazon's premier database offering. So let's look at the capabilities of these different RDS types. So you can group PostgreSQL, MySQL, MariaDB, Oracle, and SQL Server all into the same category of database within RDS. They have the same basic features. So when you pick your engine type, when you're creating a new database, you can pick PostgreSQL, MySQL, MariaDB, Microsoft SQL Server, Oracle, and you'll get the same capabilities. You'll get a version, and you can pick production, dev, test, or the free tier. And your availability and durability are limited to multi-AZ deployment, where you can create a standby instance, and that standby instance is in a different availability zone. We created this when we built out our lab in a previous video. And for your connectivity, you can choose one of your VPCs. But for Aurora, you have many more options, and it's a much more powerful database within RDS. That's why it's the recommended and premier database within RDS. So with Aurora, you have options of either MySQL compatibility or PostgreSQL compatibility. And you can choose your database location as either regional or global. So you can have a global database where you can provision your Aurora database in multiple AWS regions. And writes in the primary AWS region are replicated with typical latency of less than 1 second to the secondary AWS regions. So notice it's secondary AWS regions. You can have a primary in one region and secondaries in multiple other regions around the globe. That's pretty impressive. So with Aurora, you can also have multiple readers or writers, or you can build your database as a serverless database. So the features are one write and multiple readers, multiple writers, one writer and multiple readers for parallel query or serverless. And with serverless, you specify the minimum and maximum amount of resources you need, and AWS scales Aurora to the capacity based on the database load. So now we can build our databases as serverless as well as our processes as serverless. And as far as availability and durability for Aurora, you can create your multi-AZ deployment where you can have Aurora replica reader node in a different AZ. And then finally, let's talk about some of the other features of Aurora that are important for you to understand when you choose your database solution for your architecture. So again, it can be a MySQL or PostgreSQL compatible, and it's a database type that's built for the cloud, as we've seen with all of its capabilities that are unavailable if you don't build a database in the cloud. So it's distributed, fault-tolerant, and self-healing, as we've seen. It auto-scales up to 64 terabytes per database instance. And you can have up to 15 low-latency read replicas, as you've seen around the globe. You can get point-in-time recovery. It has continuous backup to S3. And, as we've seen, we can replicate across 3 availability zones within a region. And you can build globally distributed systems using the Aurora Global Database feature, as we depict here in this diagram. So one Aurora database can span multiple regions. So we have an example here where we have a region in the Americas communicating with replicas in Asia-Pac and Europe. And so we have our globally distributed, and this could be serverless, Aurora database. So it replicates data with no impact on database performance because, as we've seen, the replication is sub-second around the globe.